Ranak everybody, we continue a video about Ansys. It's a course of Ansys Workbench introduction, and today the fourth presentation about custom systems. As you maybe remember, as we talked in previous video, Workbench, it's a project where we create a schema, a pipeline of our design investigation process. We use different objects, we connect it to one each other, and that helps to create a lot of very different ways of simulating different complex tasks and so on. All these objects are placed on a toolbox in several collections. The most commonly used collection is analysis system. It contains objects that already ready to use for simulation, and all these objects create something like this, and this object, for example static structural or even someone else, contain stage, and those stage run application from component system. We talked about this on a previous video, and today we talk about custom systems. So what is custom system? With custom system we can create some number of pre-described objects or pre-described collection of objects with connection that help you to solve more complex tasks that in analysis system. It's task you can see here. It's some task for additive manufacturing, inherent strain, thermal structural. You see two different analyses. Both of them have preferences that we investigate process of additive manufacturing, and we create thermal analysis, and then we create a structural analysis, and we can obtain the strains and stress which will be on the end of process of printing. And for usage of this printed construction, it will be pre-stressed strains and so on, so it will be stresses and strain which before use, but in reason of process additive manufacturing we get those strains after printing process. So in reason that we obtain the strain and stress, and then we can use those strain and stress for for next simulation as pre-stressed solution. It's called inherent strain. Also we can create FSI. FSI is fluid structure interaction, when we need to solve CFD and structural tasks, and we send result of simulation from CFD, such as pressure or, for example, temperature, to static structural or transient structural. And for structural tasks, pressure, temperature, and some other things came as input parameters. We need to use one geometry, but we can suppress some parts, and for fluid flow and for structural task we can suppress different part of geometry. We have two different objects, FSI CFX and FSI Fluent. It have difference only with the solvers that we will use for creating CFD analysis. Also, we can create some additional tasks, for example, pre-stressed model. As we talked previously, we can do model analysis without pre-stressed, with general construction geometry without including information about loads, but sometimes those loads are changing frequency, model frequency, and modes. So sometimes we need to calculate pre-stressed regime and then send those information to model calculation and use them for obtained result for pre-stressed construction. As example, you can remember any musical tools like guitar, and when you change load for tension, you change frequency. That's how it works. Additionally, when we talk about random vibration, when we talk about a response spectrum, we need to understand that random vibration response spectrum harmonic analysis needs a model analysis before we can do those second type of analysis. So, for example, here a model analysis can be done without static structural, but with static structural we can obtain some different result, and if we don't use structural laws, we can obtain not real result. But for those type of analysis, for random vibration and response spectrum, we can't do analysis of vibration and response without model analysis, because list of frequencies and list of modes are used for creating second type of analysis. And also we have prescribed thermal stress analysis, so we can do steady state thermal. We can obtain definition of thermal distribution through this calculation. And as you know, when objects have difference in temperature, it change his size. If we give additional temperature, it in most cases stay bigger. If we try to call this object stays smaller. So sorry, it's airstrike. When we create those type of analysis, we have distribution of temperature, so we have in different places of our object different temperature, so we have different changing of volume in every place, and we have deformed structure with stress and strain from thermal distribution. So this how thermal stress works. And as you see, all this object create two objects from analysis system and create links. So in fact, you don't need to use this custom system. You can create those type by yourself. You can choose from analysis system steady state thermal. You can select static structural, drag and drop it to solution, and you obtain those schema with two couplet analysis. Also, we need to say that all those analyses have link only in one way. So the second analysis take some information from the first. If you need more complex task, you need to create or couplet field analysis, or create additional component which will couple your analysis, or do it by hand. Also, you need to know that you can create user specified custom system. If you have a schema with number of tasks, with number of objects, and those objects have some links, you can select those objects as you see here on animation. You can create a custom system, and then it appears here, and you can use it for create new bunch of this custom object. So something like that work our custom object. We don't talk more deeply because we talk about different type of analysis in previous session. So that's all. See you later.